Hello everybody! In this video I want to show you how we can derive the equation for calculating the pH of a weak acid. And we defined the pH of a solution as the negative logarithm. So pH equals the negative logarithm to the base of 10 of the proton concentration of that solution. That was our starting point for pH. Likewise, we said that the pOH of a solution is the negative logarithm to the base of 10 of the hydroxide ion concentration. But that's not something that we now need here. Now, we said that for a strong acid, we could say that the proton concentration of the solution is approximately the concentration of the acid. So if we write the acid as HA, something like that. And then for the strong acid, our pH calculation would be negative log of base 10 of the concentration of the strong acid. Now, what does strong acid mean? Strong acid means that the acid is almost completely dissociated in water into proton and the conjugate base. So strong acid basically means that we've got HA, and that dissociates almost completely into protons and the conjugate base here. And there's hardly anything left of the HA. Now, but what happens if we have a weak acid? In a weak acid, we still have we still have this dissociation. We still have HA, but because it's a weak acid, this acid doesn't want to easily let go of the proton. And it would still be, we get HA times A minus. So we could write the dissociation equation, Ka equals the proton concentration times the A minus divided by the concentration of the acid. Now, if this is a weak acid, this term will still stay large. This term here is small, and correspondingly this term is also very small. And therefore, we can no longer use this proton concentration here in our pH calculation because we don't know how big this proton concentration actually is. So what we can do, however, is we can do a little bit of algebra and a little bit of sort of mathematical trickery here. We can say, of course, the concentration of the proton would be the concentration of the A minus. And therefore, if we set this as x, then we can write for this equation as Ka equals x, because H plus the proton concentration equals A minus, we can write x squared. And of course, what is this HA? That is, of course, our initial concentration, initial acid, after we have dissociated it, so that would be minus the concentration of this X. So we would have concentration of HA minus X. Now, if it is really a weak acid, we find that this term here, HA minus X, doesn't change very much because the acid doesn't let go of the proton very easily. So it means this is roughly our initial concentration, HA, still. So we can really write this as Ka equals x squared, and this x squared, of course, is our H plus, if we like, divided by HA. Now we can rearrange this equation, and we can say x squared, and we must not forget this is the proton concentration, squared, equals, I can write this here, Ka times the concentration of the acid. Okay, so what can we do with that? Now, the easiest way is we take both sides of this equation here, negative log 10. What do we get? We get negative log 10 of the proton concentration squared equals negative log 10 of Ka times the acid concentration. What can we do with that? Now we can apply the rules of a logarithm, and we can say basically we can simplify this as 2 times negative log of the proton concentration equals, now what does that give us? That gives us negative log of Ka plus negative log of the acid concentration. Okay, so what do we have? We know that negative log 10 of the proton concentration, this is just simply our pH. It's 2 times pH equals minus log Ka, of course this is log to the base of 10, that of course is pKa, plus, what does that give us? Well, we can't do a lot with that, plus minus log of HA concentration, the concentration of the weak acid. So we have 2 times pH equals pKa minus log of the acid concentration. Or we can say pH equals 1/2 of pKa minus log to the base of 10 of the acid concentration. And that is a really nice equation that we can use whenever we want to calculate the pH of a weak acid, so for example, if we have a pKa equals, say, 3, and we have a concentration of the weak acid equals 0.1 molar, we can calculate the pH. pH equals half of, well, we've got the pKa, 3 minus the log of the acid concentration, 0.1, and it needs to be in molar. So we have 1/2, 3 minus log to the base of 10 of 0.1 equals -1. So this gives us 1/2 of 3 minus -1, that gives 4. So here the pH would be 4 divided by 2 would be 2. So that is how we can use this equation for a weak acid to calculate the pH. So I hope this makes sense, and thank you very much for watching.